Hello, you're welcome to Master T Math class. And here in this class, let's look at this topic, coordinate geometry, equation of a straight line. And the first thing we are looking at here, let's look at the gradient of a straight line. On the word gradient, sometimes you can call it slope, gradient or slope of a straight line. Now here, if the graph of a straight line is drawn in a Cartesian plane, they have the y-axis and the x-axis. Assuming this, here we have the graph of a particular straight line, then the gradient of this line here is gotten by finding the change in y over the change in x. So here we have delta y, which is change in y, over change in x, delta x. That is, when we trace this here, we have the upper value here is y2, and here we have y1, and same thing here we have x2, then we have x1, which implies that gradient from here of this line will now be equals to change in y over change in x, which is also same thing as y2 minus y1 over x2 minus x1. So this here we have the formula for gradient or slope of a particular line. Now, let's look at some examples from here. Find the gradient of the line joining the following pair of points. Like we have this point given here. Find the gradient. So example, find the gradients of the line joining the following pairs of points. The following pairs of points. The first one here, we have point 2, 1, and point 4, 2. Then the second one here, we have point 2, 0, and we have point -1, 3, and also the third one, we have point 1, 3, and also we have point 5, 3. Now let's look at the solution here. From what is given here, what we are finding is the gradient of the line joining this point. From the first one, we are given these 2 points, which is 2, 1 and 4, 2. From here, we should note that here we have it in ordered pair. That is in Cartesian plane, we have it ordered pair in form of x, y. And here, we can say this is x1, y1, the first point. And here we have x2, y2, that's the second point, in form of x, y. Then the gradient we are finding now has a formula. And the formula for gradient is given as y2 minus y1, then over x2 minus x1, which implies here we substitute, and here y2 here is 2, so we have 2 minus y1 is 1 here, so 2 minus 1 over x2. x2 is 4, then minus x1, that's 2. And when we solve from here, 2 minus 1, that's 1, over 4 minus 2, that's 2. So the gradient here is therefore 1 over 2 in the first question. Now, and also, similarly, the second question here, finding the gradient as well. We write out the points, that is, we have 2, 0, and minus 1, 3. So we look at this as the first point in form of x1, then comma y1, and here second point, this is x2, y2. Then the gradient, now from the gradient formula, we have y2 minus y1 over x2 minus x1. And when we substitute here, y2, that's 3, then minus y1, that's 0, then over x2 minus 1 here, then minus x1, that's 2. And this becomes 3 minus 0, that's still 3, then over minus 1 minus 2, that's minus 3. And of course, 3 over minus 3 here give us minus 1. So the gradient for the second question here is minus 1. And also, we solve the third one here. We look at the gradient of the line joining these 2 points. That is, from the point given, we have 1, 3 and 5, 3. And we can see this as the first point, x1, y1, and this as the second point, x2, y2, which implies that here gradient from the formula, we have it as y2 minus y1 over x2 minus x1. That is here, y2 here is 3, so that's 3 minus y1, that's also 3, then over x2, that's 5, then minus x1, that's 1. 3 minus 3, that's 0 over 4, and 0 over 4 here is still 0. So the gradient for the the last question here is 0 from here. And also, we can get the gradient of a particular line without first drawing the line. Once you know the equation of the line, we can derive the gradient of that particular line using the formula for gradient intercept form. So if we are given equation of a particular line, we can easily get the gradient using the gradient intercept formula. Gradient intercept form. That is, from here, normally any linear equation might be in the form of ax plus by plus c equals to 0. That's general form. We can, rearrange this in any way we like. Now, for gradient intercept form, we have to make y the subject, and y will now be equals to mx plus c. So this formula refers to as gradient intercept form, where m here is serving as the gradients, and here we have c here as the y-intercept, that is the intercept on the y-axis. And also we can get the intercept on the x-axis. And intercept on the x-axis is minus c over m. So minus c over m is our x-intercepts, intercepts on the x-axis. So these formulas are very important. And with that, we can look at some examples here. That is, determine the gradient of the following linear equations. Number one. So, example, here we determine the gradient. Determine the gradient of the following. The first one, we have y equals to 2x plus 4. The second one, we have y equals to 3x plus 2. Then the third one, we have y equals to 4. The fourth one, we have 2y equals to 3x minus 4. Now, here we determine the gradient. From there, solution, the first one, when we compare what is given here, which is y equals to 2x plus 4, compare it with this general form, which is y equals to mx plus c. It is easy to note that since m here is a gradient, it means that therefore gradients here will simply be equals to 2 because coefficient of x is gradient. So that's the gradient for the first one. Now, the second one, also from what is given here, we have y equals to 3x plus 2. It is also easier to see here, comparing with the gradient intercept form, we'll see that the coefficient of x here is 3. So we can now say therefore gradient here is equals to 3. And also from the fourth one as well, when we look at that, the third one rather, we have y equals to 4. When you compare y equals to 4 with what we have from here, we discover that we don't have anything variable x, so no coefficient of variable x. Therefore, gradient here will simply be equals to 0 from here. So that's the gradient. So no gradient. And the fourth one here, okay, let's clean this so that we write the solution out on this side. Number 4, what we have there is 2y equals to 3x minus 4. Now here, we need to compare this and rewrite it in this format. Y equals to mx plus. It means that we make y the subject. Y is standing alone on one side. So when we divide through by 2 here, so divide this through by 2 from here, it implies that here 2 cancel out and we have y now equals to 3 over 2x. When we separate this, then minus 4 over 2 here, that's 2. So now comparing this now, it's clearly, we see here that the gradient, which is the coefficient of x now, is equals to 3 over 2. And in this case, the y-intercept is minus 2. So that is that. You are welcome to Master T Math class. Thank you for joining us. Give a thumbs up and also share this video. And also your reaction is welcome. God bless you. Now, when we look at some further examples, let's quickly write the gradient and the y-intercept of the following to buttress this particular gradient intercept form. It implies here, write down the gradient and the intercepts of the following equation for straight line. So let me quickly write the equation. Write down the gradient, and the y-intercepts, and the intercepts, not only the y-intercepts. We have y and x intercepts, and the intercepts of the following equations of straight line. Of the following equation of straight line. Now, the first one, we have y equals to 3x minus 2. Second one, we have y equals to 2x. The third one, we have y equals to 3. And fourth, we have y equals to 1 minus 4x. And the fifth one, we have 3y equals to 3x plus 6. Now, let's quickly look at this solution here. We are writing out the gradient and the intercepts. For the first one, we have y equals to 3x minus 2. Now, let's compare this with y equals to mx plus c. And here, don't forget that m here is a gradient. M is gradient. So let's write this out here. In this formula, m is a gradient, c is the y-intercept, and minus c over m is the x-intercept. Now, let's work with this now. It implies that the gradient here, from what we are writing, first one, let's label it as a gradient. Comparing this with the formula, gradient here will be 3. So y-intercept, B now, y-intercept here, comparing that with the formula, y-intercept equals to minus 2, as y-intercept here is c. And also x-intercept here will be equals to minus c over m, and that means we have minus 2 over 3, and which give us minus times minus, that's plus, that's 2 over 3. So this is y-intercepts for this particular equation. So we have the gradient, we have the y-intercept, and we have the x-intercept. Now also, looking at the second question here, we have y equals to 2x. Now, the first one, gradient here, gradient from here, comparing this is 2, gradient is 2, and y-intercept is 0 here. So because there is no intercept, no constant added here, and x-intercept also will be 0. So that is that. And also, the third one, we solve the same way. That is, from what is given here, y equals to 3. When we compare this, the gradient here automatically 0 because there is no x, there is no variable x, so we can't have gradient. Gradient is the coefficient of x, so we don't have gradient here. So that's 0. And we have y-intercept. Y-intercept here is 3 automatically. And x-intercept, which is minus 3 over 0 now. So this is undefined according to mathematics. And you have something divided by 0, as it doesn't exist there. So let's look at the next one, number 4. we have y equals to 1 minus 4x. Now, when you look at this here, we already have y as the subject of the formula when we compare with the general form of the gradient-intercept form. And therefore, the coefficient of x here is minus 4. So, gradient here now is equals to minus 4. So, it's like we can even rearrange it, and rewrite this as minus 4x plus 1. So, it's still the same thing. That implies that gradient is minus 4 and y-intercepts here is equals to 1. Then x-intercepts is equals to minus c over m. That's minus 1 over minus 4. Minus cancel minus. That's 1 over 4. So that is that. Then let's solve the next one, number 5. Also from number 5 here, so we are given 3y equals to 3x plus 6. Now we need to make y the subject. It implies we need to remove this 3. And how do we remove this 3? We can divide through by 3. Divide this equation through by 3. So we divide here by 3, divide here by 3, divide here by 3. Here 3 cancel each other. We are left with y equals to also 3 cancel each other here. We are left with x, then plus 6 over 3 here. That's of course 2. So this is the equation we have now. So which implies the gradient here, coefficient of x is the gradient, and the gradient here is therefore 1. Y-intercept now, y-intercept here is 2, and x-intercepts here equals to minus 2 over 1, which is minus 2. So here we have solved this 5 problem to illustrate the gradient and intercept form. So you have been watching us at Master T Math class so far. I believe you are enjoying this class. So help us to share and give a thumbs up, and also subscribe for more videos. Give us your maximum support, and thank you. Now, by God's grace, we are going to be continuing from here in our next class. So don't miss out. We are looking at coordinate geometry, that's straight line. We have different form of equation of a straight line. One of it is the one we have looked at now. So we are still going to look at some others. And we look at this one too properly in our next class. And God bless you. Have a wonderful day. Enjoy your, your festive period. And God bless you. See you next class. Bye for now.